Okay, these are notes for 5.4, solutions of systems of linear equations, and these are basically like special cases. So you'll notice with this first section here, our core concepts. These are our little notes. The big idea here is there's three types of answers we can get with system of equations. If you graphed your linear equations and they intersect in one spot, that means they have one solution. Now notice in this next one, the lines are parallel and they never intersect at all. If they never intersect, that means there's no solution. And then if you graph two lines and they just so happen to be identical, that means there's infinitely many solutions. So when you graph, it's easy to tell how many solutions there are, but sometimes when we're doing these algebraically, we want to show you what happens. So what's going to happen, I'm going to add to these notes, is on this first part, one solution is normal. Okay, that's going to be normal for us. But it's no solution. This is when that you get no variables eventually, no variables, and you get, let's say, two different numbers equal to each other. So for an example, you might get something like 4 equals -6, and that's not true, so that would be no solution. Infinitely many solutions is where you have no variables left, and you have some number equal to itself. Sort of like 4 equals 4, which is true, and that would make an infinitely many solutions. So let's look at example 1 here and see how that'll work out. This first one, it's probably where we could graph them, but I'm going to do actually an elimination with this. And I know elimination, we typically will have these where they are, actually, let's not do elimination. Let's go ahead and do substitution here. So I'm going to go ahead and take this 2x plus 1 and plug it in for this y right here. And that's going to give me 2x plus 1 equals 2x minus 5. Now, if I subtract 2x from both sides, you'll notice I get 1 equals -5, which is not true, so we get a no solution. Now, this next example, example 2, is where you would have one that we could do elimination. So on this one, I'm going to, let's say, multiply this top by a -2 on both sides. When I do that, I'm going to get a positive 4x. I'm going to get a -2y and then a -6. When I line these up, notice my 4x's cancel, my 2y's cancel, and I get a 0, and then 6 minus 6 is 0. This is a true statement, which means we have infinitely many solutions. Now, if you want, you can go ahead and pause the video and do these next 4 on your own, and then that will be the end of these notes. All right, now that you've done the on your owns, this first one is infinitely many solutions. The second one is no solution. The third one's a little bit of a curveball here. This one actually is the answer 2, comma 1. And then number 4 is no solution. All right, we're going to take a break from here and be done with these notes. If you have any questions, please reach out.